the third law of motion, or the law of action and reaction. It is said that we cannot touch something without being touched in return. More elegantly, we cannot even move a finger without moving the stars. These statements originate from a fundamental property of physics. When a body A exerts a force on body B exerts an equal and opposite force on body A. To put it more succinctly, forces can never exist in isolation, only in pairs, or every action has an equal and opposite reaction. A simple activity can show us the validity of this statement. If we take two identical spring balances and connect them and pull any one of them, the other will display the exact same reading, no more and no less. This is because the spring balance is measuring force. This implies that the forces exerted on both balances and on each other are identical. There are some crucial things to understand about the third law. Number 1. Action and reaction do not take place on the same object. Number 2. While the forces are equal in magnitude and opposite in direction, the accelerations of the objects involved may or may not be the same, as this depends on the inertia of the objects as well. If the two objects are connected, the net acceleration of the objects taken as a whole will be zero. A prominent example of the third law in action is the firing of a gun. The gun exerts a large force on the bullet. By the third law, this force cannot exist in isolation. The bullet must exert an equal and opposite force on the gun. However, since the mass of the gun is so much greater than that of the bullet, it will recoil only slightly, while the bullet will be accelerated to a very high speed. Another example is that of a boater trying to leap off the boat to the shore. As the person jumps off the boat itself will recoil due to the force exerted by the person on the boat. Thus, both of objects in this system shall move. This is another example of the third law in action. So this is a summary of what we have learned.